In exercise 32A, I assigned this question because it's interesting. In fact, if I were writing your exam, I would seriously consider putting in something like this. I wouldn't give you this, that's too easy. But can you see what's interesting about it? Like this is what you're asked to prove, okay? You got some point, any point on the ellipse, actually, and they want you to show, rather, that the distance from that point to both of the foci, when you add them up. So this distance plus this distance, when you add them up, apparently you get the major axis. That's 2A, isn't it? Okay. And the reason why I like it, and it's kind of a shame that I assigned it to you because now I can't put it in the exam, but I can find other ones. The good thing about it is that there's no formula to it. There's no formula. It's about whether you understand the geometry of this shape and how the features relate to each other. And there's no like, oh, okay, factorize this and then complete that square and then blah, 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 which you can go through rather thoughtlessly and mechanically. You can't get away with it on this kind of question. So, how do you go about doing it? Okay. Now I could just solve it for you, okay? But that'd be a little bit boring, wouldn't it? How are we going to work with this thing? Okay. Where might you start? Now the first thing I've done is, and if you have tried this question without drawing it, you are kidding yourself, okay? If you have tried it and have drawn like a little thing which is, like this big and you've got everything scratched in, you are still kidding yourself, okay? Even if you don't actually label anything on there, the very act of drawing it often, this is the same thing with circle geometry, by the way. You got circle geometry proofs. Have you ever had that where it's in the textbook and you just stare at it and you're like, it's been 10 minutes and I haven't gone anywhere, okay? Tip number 1, draw the thing and draw it big. Often the process of drawing shows you the connections that you need. Anyway, that's an aside. What information could I add onto here that might be useful to me? Okay. Well, I've got PS and PS dash, my two foci, right? And I have them related to this point, okay? Now, I want to keep in mind, this is an ellipse, right? So I know heaps and heaps of other stuff, other information about this ellipse and how everything relates to each other. For instance, 2A, it's the major axis, yeah? So I'm automatically now thinking about any horizontal distances that are possibly related to what I've got, okay? So for instance, think about, draw it in like so. This distance here, okay? Now, by the way, rather than saying this distance, I want to put some names on this, okay? Because then I have language to describe it. So here's a distance that's important. I'll call it D1. This distance here, oh, that's really badly drawn. Oh well, it's perpendicular now because I said it is. That distance there is related to D1, so I'm going to call it D2. Okay. This other distance, the other focus, I guess I'll call that D3. I'm missing one. I guess I'll go to the other side, like so. I'm going to call this D4. Okay. Now, by the way, the reason why I'm going both ways, okay, is because when I compare this distance from this point to this focus, I can't just choose which directrix I want. There's one directrix and one directrix only that matches up with this focus, right? And it's the one on this side. So these two match up, D1, D2, and these two match up, D3, D4. Okay. All right, now, let's see here. D1 and D2, they're from the point to the focus, and then the point to the directrix. How well do you have this in your head? They are related to each other, those distances. D1 and D2, what's the relationship between them? We even give it a name. It's the that is the eccentricity, right? How would I write it? What ratio is it? Which one's on the top? PS. It's this one. It's PS on P. Well, this is kind of D, isn't it? This was what the question said, right? But I'm now rephrasing it in terms of all this different language, aren't I? Okay. So what I have here, if I were to write it in what I've got, these are the two distances I'm after, right? D1, D3. Okay. So I somehow want to connect these oblique lengths with these horizontal lengths. Okay. Well, the connection is the eccentricity. Okay. So I suppose I could write this as, how can I rewrite this? What would be a useful way to write this? I'm going to let you think about that for a little while. I'm going to let it simmer in your head. Okay? In the same way as I said this, I can also say the eccentricity is equal to the other ratio, can't I? It should be the same. D3 on D4. Yes? All right. I don't quite have all the pieces there yet. Right? I have some relationship between the lengths I'm after and the lengths that I actually know something about, the horizontal ones. Okay? What else can I use here? What else do we know about this shape that we haven't put on there that will be useful to us? Okay, so the directrices rather, they each have an equation, don't they? Now, the reason they'll be useful to us is for two reasons. Number one, the distances between them are well defined. I can know exactly where they are because I know where these are, right? Number two, what are the equations of the directrices? What's the equation of this one? It's A on E. And the other one is minus A on E, A, and E. Okay, I almost have all the pieces in place. The question is, how do I put them together? Okay. Think with me. This part's hard for me because I'm not sure what next step to give you which doesn't just completely spoil it. Okay? I want to give you a little clue which will sort of push you over the edge, but you have to climb over, if that makes sense. D2 and D4, right? They're not just random lines, right? They're connected, actually. So I actually know a whole lot about them. D2 goes from all the way through to here, and here, and D4 goes all the way to the other directrix. Okay? So therefore, I ought to be able to say that D2 plus D4 is equal to 2A on E because this is A on E, and the absolute value of this is also A on E. So those, when I add the lengths, that's what I get. 2A on E. Okay. Keep your eyes on where you need to get to. I'm really close, aren't I? I've got the 2A there. I just have this E in there. How am I going to rearrange this thing? Okay, so this D2 and the D4, here's an equation now, a statement which I know is true. I somehow need to get rid of the D2 and the D4 and get the 1 and the 3. Well, I've got enough pieces to do that, don't I? How do I write this? Well, I need to sub out D2, so I'll make it the subject. D2 is equal to D1, and then the E comes down. Similarly, D4 is D3 on E. These are parallel statements. Okay? So therefore, I suppose if I want to do it properly, let's name this, name that, and say sub, I should put it underneath, sorry. Sub 1 and 2 into 3. If you want to do it formally. Okay, you ready? D1 on E, D3 on E, 2A on E. There it is. Okay. D1, D3. Ta-da. Now that's interesting, right? Not this part of the question because it's very hard to ask a question about this, but that should tell you something interesting about this. Why is it equal to the major axis? Like I proved it algebraically, but how come it is that? How come those two are going to give you that length? What if I moved P somewhere else? What would happen? What would you expect to happen? What if I put P in unusual places, like here or here, special cases? What would it reveal about the ellipse? And that's for you to think about, okay? But this is the way I would do it. Probably if I wanted to add one more thing, I would probably say at this point, before I say them, I would say by definition. Or if you want to be really formal, by definition of the locus of the ellipse. Because that's where E comes from, okay?